Hi, my name is Muhammad Azmi bin Azmi. Today, I will explain about the experiment T3, which is a determination of jet velocity and nozzle efficiency. The objectives of this project is to study characteristics of nozzle and the parameters that affect its efficiency. Next, the procedure. First, close the air inlet control valve and open the chamber pressure control valve before proceeding further. Ensure that the contacts are clean, that the battery is in good condition, and that the impact head is fitted to the end of the cantilever. Also, check that the micrometer dial has been correctly zeroed and that cantilever load or deflection graph is available. Next, unscrew the null nut at the top right hand end of the chamber. Withdraw the nozzle mounting sleeve and assemble nozzle number 1 into the unit. Next, turn the diverter valve handle to the upward position. And then, with the chamber pressure control valve fully open, adjust the inlet control valve to give a constant air inlet pressure 600 kPa gauge. And next, rotate the micrometer adjustment screw until the voltmeter and the lamp indicates that contact is just made. Greater sensitivity is obtained if the screw is adjusted so that the voltmeter indicates about 0.5 volt. And then record the pressure, temperatures, air mass flow rate and dial reading. And next, increase the chamber pressure about 100 kPa gauge and repeat the above step, making sure that the inlet pressure remains constant. Repeat the test at other chamber pressures. And finally, repeat the whole test with other nozzles. And precautions. Make sure the tools are in a good condition. Wearing a pair of gloves and lab coat to avoid any injuries. And lastly, clean the workplace after finish the experiment. Okay, now I will show how to transfer this result table to the Excel. This table I've already made it in Microsoft Word. Done. And then the answer for the data nozzle 2, I have made a calculation and I just type the answer here. Now I will show how to draw the graph using Microsoft Excel. First, we make the graph MS flow rate observed versus overall pressure ratio for the X values, which is overall pressure ratio, and for the Y values, which is MS flow rate observed. And this is a graph for MS flow rate observed versus overall pressure ratio. And next, we make a graph MS flow rate correct versus overall pressure ratio. We just change the Y value. We change the Y value with MS flow rate correct. And this is the graph for MS flow rate correct versus overall pressure ratio. And next, for the third graph, we make nozzle efficiency versus overall pressure ratio. Okay, this is for the graph. Okay, this is all result for this experiment. Nozzle 2, and then nozzle 3, and then nozzle 5. And next is graph for nozzle 2, and then graph for nozzle 3, and then graph for nozzle 5. And lastly, for the conclusions. In conclusion, from the experiment, I can study characteristic of nozzle and the parameters that affect its efficiency. I can conclude for all three nozzles from the graph of nozzle efficiency against pressure ratio drawn that the graph decrease and increase somewhat before decreasing completely when the pressure ratio increase to the value of 1. I can also conclude that the value of the pressure ratio is 1 at 0 efficiency. Other than that, I can learn how to use all the apparatus used in the experiment. I can also calculate the data by use the equation given. So there is a lot of lesson that I can learn from this experiment. For the recommendation, the test can be done repeatedly to get the accurate values. Ensure that nozzles will connect tightly to the hose. Student must read the procedure of the experiment beforehand and aware of its safety precautions while handling this experiment to avoid unnecessary error and accident. And for the application, a Pelton turbine, also known as impulse turbine, is a type of water turbine that is often employed in the hydroelectric projects. A water reservoir is usually located above the Pelton turbine when it used to generate energy.